Alright, so your teacher can't teach you integration? Let me show you. Alright, so we're going to be doing integration basics. Alright, so what actually is it? Pretty much, we have a graph, and maybe it's something like this, like a parabola. And what we want to do is pretty much find this area under it. I want to find how many meters squared, for example, this area is just shaded. And we can do that in a second. Alright, so pretty much the integration symbol is this. This little loop thing is the symbol. And let's say you are trying to find the integration of a parabola. So the function is going to be x squared, because that's the most boring parabola. Alright, and remember when you write it out, there's going to be a little dx thing at the end. For now, don't worry about this. It doesn't matter really until you get into higher math, but don't worry. So you want to integrate this. Well, there is this simple little formula that we can do. So integral of x to the n number is equal to x n plus 1 over n plus 1. Alright, let's take this example. Example number 1. What do we do? Alright, so x squared dx. We want to find the area under there. So we want to get the integral. So this is the integral. Yes, and I forgot, by the way, it's plus c, plus a constant at the end. Just remember to add the plus c. You don't have to substitute any number, just plus c at the end whenever you write the integral, alright? So let's do this one. So x squared. So n in this situation is 2. So n plus 1 is equal to 3. So therefore, the integral is simply x cubed over 3. And what this is it's pretty much it's the function that will give us the area under it, is what it is. So yes, plus c. Remember the plus c, or you'll probably get marked down. Alright, so that's that. And I'll show you another example. So remember, all it is just finding the area under a curve. That is it. Finding the area. If it's like that, you're going to find this area here. Whatever curve it is, just under there. We want to find how many meters squared that is, for example. Right. So let's do a different one now. Let's do x cubed plus 2 dx. So I'm going to find the integral of this. Alright, remember, you got the integral for xn is equal to xn plus 1 for n plus 1 plus c. Alright, plus c, remember please. Alright, this shit. So x cubed plus 1 over 3 plus 1. And, alright, for integrals, note, when there is a constant like 2 or whatever, just a normal number at the end, it could be minus whatever, just a constant, what you do is you just put an x on the end. That's it. Because you can think about it as like, alright, so this first term goes into x 4 over 4, but this 2 like doesn't have an x, so it's kind of like 0 terms of x. So you just add 1, So it just becomes 2x. So just a constant. So if it was 3, it becomes 3x. If it was negative 3, it'll become negative 3x. Right, we get that down. That's like the chill stuff, right? So x plus 2x is what it is. Plus c. That's the integral for this function here. Now, alright, what if you have something a bit different? A bit more complex. And didn't you say something about the area? Where's the meters squared from this? Alright, so before, we were just finding the function that gives us the area. And that's called, alright, so the indefinite integral. Alright, because we just find the function and we don't find the actual area, just indefinite. So for example, this one here, that is an indefinite integral because it's just, we just have the function. We're not getting like whatever 10 units squared on this. It's just this is what you get from an indefinite. Right. But let's change it up, alright? Instead of just this, we're gonna add a couple extra terms onto it. Right. We're gonna add 2 and 2, right? To make it kind of simple. Actually, no, let me make that a 0. Right. And we're just gonna use the same function as that, but except it has 2 numbers there. Okay. So this is what we call a definite integral. Alright, because it has these 2 numbers here, which are like the bounds, for example. Like, I'll show you. What these 2 numbers mean is, so let's say you have like a little thing, let me put it down here, and this x cubed, when you plot it, it looks like this, and these bounds is like where you want to find the area, okay? So 0 is the end bound, so that's 0 there, and negative 2 is the other one. Let's say this is negative 2 here, so put like a line down there, and kind of it means you just want to find the area here between negative 2 and 0. Alright, between those 2 x coordinates. We just want this area, we do not want this. No, just that. Right. So that's what you put in, and well, how do you get it? Okay. So if you want to actually find the area, you want to get the definite integral for something, you actually still need the indefinite, because it's kind of like the formula, and so we already know it, so that's helpful. So it's equal to x4 plus 4 plus c is the indefinite for this function here. So what we want to do is we want to substitute these values in, alright? I'll show you how to substitute. So it is the final, okay, the final value, which is on the top always, final minus the starting value, okay? Okay, so we'll just add this for a second. So this just signifies that we're gonna find this value of the function between these 2 numbers, between negative 2 and 0. That's just how you write it. It's nothing special. And equals, so final one, so the final is 0, so that's important, right? So it means the first bit we're going to do is we're going to have this function here. Instead of x, we're going to actually put 0 in. So 0 to the 4 over 4, and then ignore the c, because it doesn't matter for this. So 0 to the 4, divide by 4, and then you minus from the start, alright? And the start is the -2. So minus this function subbed in with -2. So -2 on top of there, and to the 4th power over 4. And so we can calculate this. So this one is just going to be 0. So it becomes 0 minus this number here. So what's -2 raised to the 4th power? That is going to be 16 over 4 equals to 4. So such as -4. And you can write units squared. That's just the general way of writing it. If they don't give you like meters or whatever in the question, just put units squared. It usually works out. Or you can even just put -4, depending on what your teacher asks for. But she'll be right. So that's the answer there. But you might be wondering, how do you have -4 area? That doesn't really seem right, alright? So what it means is just, it's negative because it's just under the x-axis. So that's x negative. So that's why it's a negative area. But if you want to just know the actual area of that, it's literally just, you literally just turn it to positive. So it's literally just 4 units squared. That's it. So yeah, that's what it is. And we'll try a different one. Hopefully this is making more sense than the teacher, because I remember when they taught it to us, it didn't really make sense until we got a good teacher, and she was a legend. Alright, so let's do something a little bit harder. I can do -3 and 1, and inside we should put, let's do 2x 2 plus 1, and then just, yeah, it's usually just a dx, but don't worry about it, trust. So we have no clue what this graph looks like. Absolutely no clue. I don't anyway. I don't know what it looks like in my head. Maybe you do. So we want to find the area between -3 and 1 is what this actually means. Area under the curve of this function between -3 and 1. Let me drill that into you, bro. Because if the teacher has it, then they failed, bro. They failed. But it's not too late. Alright. So, let's find the indefinite first. And yes. So, what's the indefinite of this one first? So it's just 2x squared. So it becomes 2. And then, yeah, let me write it in the corner just for you. xn. Maybe write this down in your books if you haven't, because this is like the lifesaver if you have no clue. Apologies for the smallness. That's n, by the way. Right. So that equals that for most integrals, and in our case the n value is 2. N equals 2. So therefore n plus 1 is 3. So it becomes 3 and then 3. And then the 1, remember what you do with constant, you just add an x. So pretty much, or you don't add it, you multiply it, but whatever, you know what I mean? So it's 1x, or just literally just x. So if we add it there, you just remove this. That's bad. Alright. Plus, right, just ignore this for a second. Just rewrite it down here so it's clearer. Plus x plus c. That's the indefinite integral, right? This is the lovely function that gets us the area under this. So we want to find it between -3 and 1. All right, so we do the final minus start. So this is final. Final is the top, then start. If you're wondering how you can find this on a graph, final and start. Start will always be the more negative number, kind of, you know what I mean? The lower number. The more on the left, pretty much. So final minus start, we get, let's plug this stuff in, 2, and then -3 squared over 3. I'm gonna probably attempt to do this in my head, but she'll be right, hopefully. 3. So -3, and then just ignore the c because we don't really care about it right now. Don't worry about uni yet. And then, so this is the -3, so this is the final term here, and then start. What's the start one? It's 1, so 2 is 1 squared over 3 minus, no, plus, it's plus 1. Alright, hopefully I can do that math in my head. And -3 squared is 9, so 18 over 3 minus 3 minus that 2/3 plus 1. So final answer for this, 18 over 3, that is 6 minus 3 minus 2/3 plus 1, so that is 5/3. minus 5/3. Yeah. I don't know what that is on a calculator, but you can easily put it in, so she'll be right. And then units squared. Yes. And that gets the area under it. Between these values, the area is 3 minus 5 over 3 units squared. Yeah, you can put it in decimal. Yeah, you can put it in fraction, whatever you want. Whatever your teacher asks, probably, but she'll be right. Right, let's just do one last one. This one you'll probably see a bit, and it's a bit of a pain, but hopefully you get it right. I believe. Enough practice, and this shit becomes easy, bro. Trust me. I know right now it can be a bit hard, but let me show you. Alright, so let's say you have this one This one here, so x to the minus 2. What do you do then, bro, when it's minus 2? Well, this is what you do, bro. Alright, remember this formula. If you want to, copy it down as many times as you want or like to. It's because if you get it into your head, it will just stick there, bro. It will stick there if you use it. Because it's just goated. Alright. Alright, so and in this, in our little situation over here in the purple, right, our n situation, n is equal to -2. Alright, but it's n plus 1. So simply, we just add 1 to it, okay? So n plus 1, -2 plus 1 is -1. So this becomes -1 x to the -1 over, what do you call it? -1. And there's probably a better way of writing that. 1 second. It might. No. Let me think. Divided into -1. It's that. Becomes that. But if this is still a right answer, right? This is if you really want to simplify it, so like don't worry too much about it, trust. I'll remove it just because it's a bit confusing, but I remember this one is still right. If you know your index laws well, then you can like rearrange it to make it look nice, but like whatever, chill, bro. It still works. So that I plus C, of course, remember the plus C, bro, or they're gonna like minus a mark off you. Cooked. And yeah. So that's that. And let me just finish it off by giving you some other ones if you do need them. If you don't, just leave the video here. It's chill. Integral of e to the x is literally just e to the x plus c, of course. Remember the plus c or you die, bro. You die. Alright, so that's that. Is there any others? Any other easy ones? Log. Let's just do that. Integral of that is just 3x. So pretty simple. Plus c. Come on, bro. What if you have, let's say you have a fraction, x over 3 dx. Then what do you do? What do you do then, bro? Alright, so the x term here is 1 secretly. So n equals 1. Yeah, I don't know if this follows this law, but maybe, but like I can't be bothered. But so this one, n equals 1, n plus 1 equals 2. So should be, if I am correct, which I hope I am, x squared. Wait. Hold up. Before we get into that, alright, just look at a fraction, be like, okay, so that's divide by 3. Alright, we're just gonna take that right to the front, alright? So we can literally rewrite this as 3 times the integral of x dx. That makes it a lot easier, because this constant doesn't really matter. So we can just do this one, so as we normally would with these values here, so n plus 1 equals 2, so it would be x squared, and then n plus 1 on the bottom, so over 2. And then times 3. So you get that, and you're not timesing the c, you just add at the end, bro, don't worry about it. So that's the answer for that. And yeah, good luck, bro. She'll be right. Just practice, bro. Pretty much. Simple as that. Thank you.